10. Symbolizing the statement forms of syllogistic logic. Recall that the statement forms of syllogistic logic are given as follows. F1 all A or B, F2 some A or B, F3 no A or B, F4 some A or not B. These are all stated in the plural form. In order to translate these into predicate logic, the first thing we must do is to convert each plural form into the corresponding closest singular form. S1 every A is B, every A is A, B, S2 some A is B, some A is A, B, S3 no A is B, no A is A, B, S4 some A is not B, some A is not A, B. Examples of sentences in these forms are given as follows. E1 every astronaut is brave, E2 some astronaut is brave, E3 no astronaut is brave, E4 some astronaut is not brave. Note that the simple predicate is brave can be replaced by the longer expression as a brave person. The next thing we must do is to convert the specific quantifier expressions every some no A into the corresponding expressions involving general quantifiers every something is such that, consider S1. To say every A is A, B is to say everything that is A is B, or if we have persons exclusively in mind, everyone who is A is B. For example, we could read the latter as follows. Everyone who is an astronaut is brave. We know how to formalize everything everyone is B. Everything is such that it is BX, but we don't want to say that everything is B, just every A is B. How do we add the clause that who is A? Let us try the following paraphrases. Everything is B provided it is A. Everything is such that it is B provided it is A. Now we are getting somewhere, since this sentence divides as follows. Everything is such that it is B provided it is A. Adding the crucial pronoun indices variables, we obtain the following. Everything X is such that X is B provided X is A. Recall B provided A is equivalent to B if A, which is equivalent to if A, then B, which is symbolized AB. Thus, the above sentence is symbolized as follows XXBX. Note carefully the parentheses around the conditional. It's okay to omit them when the formula stands by itself, but when it goes into making a larger formula, the outer parentheses must be restored. The same thing happens when we negate a conditional. Of course, the corresponding formula without parentheses, XXBX, is also a formula of predicate logic, just as AB is a formula of sentential logic. Both are conditionals. The latter says if not A, then B. In contrast to it is not true that if A then B, which is the reading of AB. The most accurate translation of the predicate logic formula, which is logically equivalent to XX by, reads as follows. If everything is A, then this is B, where this points at something external to the sentence. This is a perfectly good piece of English, but it is definitely not the same as saying that every A is B. Next, let us consider S2 above. To say some A is B, for example, to say some astronaut is brave, is to say there is at least one A that who is also B, which is equivalent to there is at least one A and that he/she is also B. Notice that the pronoun it points internally at least one A. We know how to say there is at least one A. There is at least one thing such that it is AXX. How do we add the clause that is also B or and it is also B? Well, we are saying that the thing in question is A, and we are saying in addition that it is B, so we are saying that it is A and it is B, which gives us the following. There is at least one thing such that it is A and it is B. This is symbolized as follows. XX and BX. Notice once again that the outer parentheses are restored before the quantifier is prefixed. If we were to drop the parentheses, we obtain XX and BX, which is logically equivalent to XX and by, which may be read something is A, and this is B, where this points externally at whatever the person using this sentence is pointing toward. Although this is a perfectly good formula of predicate logic, it says something entirely different from some A is B. Next, let us consider S3 above. To say no A is B, for example, no astronaut is brave, is to deny that there is at least one A who is B. In other words, it is the negation of some A is B, and is accordingly symbolized as follows, XX and BX, which is literally read as it is not true that there is at least one thing such that it is A and it is B. Recall that X is equivalent to X, for any formula. In the above case, is the formula X and BX, we have the following equivalents. XX and BX, XX and BX. But, in sentential logic, we have the following equivalents. Check the truth table. A and B, AB. So, putting these together, we obtain the following equivalents. XX and BX, XX, BX. Thus, we have an alternative way of formulating no A is B, XX, BX, which is read literally as everything is such that if it is A then it is not B. Finally, let us consider S4 above. To say some A is not B is to say there is at least one A and it is not B, which is symbolized very much the same way as some A is B, XX and BX, which is read literally as follows. There is at least one thing such that it is A and it is not B. Let us compare this with the following negation. Not every A is B, which is symbolized just like it is not true that every A is B, thus XXBX, whose literal reading is it is not true that everything is such that if it is A then it is B. Recall that X is equivalent to X, for any formula. In the above case is the formula XBX. Notice the parentheses so we obtain the following equivalence. XXBX XXBX. But recall the following equivalence of sentential logic. A B A and B. Thus, we have the following equivalence of predicate logic. XXBX XX and BX. In other words, to say not every A is B is the same as to say some A is not B. For example, the following in effect say the same thing. Not every astronaut is brave. Some astronaut is not brave.